Hello everyone, my name is Gaurang Gupta and today we will do a ML project which is pistachio type detection. So in this project what we have to do is we have to predict the type of pistachio based on the given parameters. So here is the data. You can see we have different parameter values like area, perimeter, major axis, etc. and we have to detect this class variable. Here you can see there are two classes which are given to us. So it is a classic problem of binary classification. What is binary classification? It's just that we have two classes and we have to predict whether the data point belongs to class 1 or to the class 2. That's it. So let's start coding. First we will import all the necessary libraries: numpy as mp, pandas as pd, from sklearn.preprocessing import standard scalar, label encoder, from sklearn.model selection import train test split, from sklearn.metrics import accuracy score, confusion matrix, and confusion matrix display. Then we will import our models. So from sklearn.svm import svc, from sklearn.linear model import logistic regression, from sklearn.ensemble import random forest classifier, from sklearn.tree import decision tree classifier, from sklearn.neighbors import k nearest neighbors, k neighbors classifier, from sklearn.ensemble will import ada boost classifier, from sklearn.gaussian process import Gaussian process classifier, from sklearn.gaussian process.kernels import rbf, from sklearn.ensemble import gradient boosting classifier, import xgboost as xgb, and lastly import os. So let's run it. What happened? Oh, that will be metrics. So now our code is executed without any errors. So let's move on to the second section, which is loading the data. So for loading the data, first we will need all the file names. For this we will use this, and for file name, in file names we will print os.path.join directory name and file name. Let's run this. So here you can see we got the path for this pistachio.csv file. So now let's import our data. For this we will use pd.readcsv and then this path. Now let's run it. So the code is executed. Now we will move on to our third section, which is wait a minute, which is data pre-processing. So before we move on to data pre-processing, first let me show you what are the different columns we have. So data.columns. Here you can see we have all the names of the columns: area, perimeter, major access class, shape factors, compactness, etc. So now let us divide our data into x and y. So x will be data and all the parameters except this class parameter. So copy it and paste it. For y we will do np.array data class and we will ravel this. Now let's run it. The code is executed. So now we can use standard scalar. Again you can use any other scalar. I'm just preferring this. So x will be std.fit transform x, and then with label encoder we will use y equal to lb.fit transform y. Here you can also see the classes which our label encoder has encoded. So for seeing this we will use lb.classes. Let's run it. Here you can see we have both the classes which here wait a minute, here are present. So it has encoded both the classes. The d type is object because it returns an object. You can convert it into a list by using the list function. Let me show you. So here we get the list, but I am leaving this as an object for now. So let's move on to our next section, which is training and testing. So for training and testing we first need to divide our data into training and testing data. So let's do that. So for splitting our data into training and testing, we will declare these variables: xtrain, xtest, ytrain and ytest, and this will be equal to train test split x y. Test size will be 0.25 and random state will be 0. And I'm also using a dictionary which will store accuracy scores of different models. So accuracy scores of different models, that will be equal to an empty dictionary. So let's run it. The code is executed correctly. Now we will declare a function which will be model train and score. This function will train every model and will also calculate the score of the model. So it will take two parameters. First is the model and then the model name. So first it will fit the model with the training data, xtrain, y train. Then we will get the predictions. Y pred equal to model dot predict x test. Then we will put our accuracy and the model name into accuracy scores. Wait, accuracy scores of different models. So the name and then the accuracy score, y test, y pred into 100 to get it in percentage. So we will print the accuracy score into 100. Then we will plot the confusion matrix. Confusion matrix, it will be y test, y pred, and the labels will be model dot classes. Then we will set the disp variable, which will be the display of confusion matrix. Confusion matrix display, confusion matrix equal to cm, and display labels will be model dot classes. Then we will use disp dot plot. So wait a minute. Let's run it. Now this code is executed. Now we can move on to our models. So let's start coding our first model. It will be model equal to svc. C will be 1.2 and the kernel will be RB. Then we will call the function model train and score. We will pass the model and then the model name, which is support vector machine. So let's run it. Here you can see we have the accuracy and the confusion matrix. So now let's move on to our second model. It will be model equal to linear regression. Then model train and score, model and linear regression. Sorry, not linear, logistic regression. Logistic. Now let's run it. So now we will do this for every model. So for a random forest, we will use random forest classifier with n estimators equal to 10 and model train and score will be model comma random forest. Now we will make a decision tree model. It will be decision tree classifier with a max depth of 7 and then model train and score model comma decision tree. Now let's code our fifth model, which will be k neighbor classifier, k neighbors classifier, and n neighbors will be 7. So model, fit, model train and score will be model comma k neighbors, k neighbor classifier. Now let's run it. So now let's move on to our sixth model, which is XGBoost. So XGB dot XGB classifier objective is binary and logistic. Random state will be 42. Then model train and score will be model and XG boost. XG boost. So now let's run it. Here we got our sixth model. Now we will move on to the ADA boost classifier, which is our seventh model. For this we will code model equal to ADA boost classifier n estimators equal to 25 and model train and score will be model comma ADA boost. So now let's move on to our next model, which is a gradient boost classifier. For this the model will be equal to gradient boosting classifier n estimators will be 50, learning rate will be 0.01 or let's set it 0.1. 0.01 will be very less, so max depth will be 10, random state will be random state will be 0. So now model train and score will be model and gradient boosting. So now let's run it. We got our answer. Now we move on to our last and final model, which is Gaussian process classifier. For this, first we will define the kernel, which will be 1.0 into RBF 1.0. Then model will be Gaussian process classifier. Kernel will be equal to the kernel variable we declared, and random state will be 0. Then model train and score model comma Gaussian process. Now let's run it. So now we have all our models calculated. We have calculated the accuracy of each model, and we also printed the confusion matrix for each one of them. Now let's first see the accuracy and the name of every model we used. So for key comma value in accuracy scores of different models dot items. So key to print will be key if the length of the key is less than 28, then for I in range 0 to 28 minus length of the key to print plus equal to a space, then we will print the key to print and the value. Let's run it. Here you can see we have name of every model and their accuracy printed. So by looking at this, you can see that the support vector machine is the most accurate model of all the models we used. You can change the parameters to make some of the models more accurate than support vector machine, or you can make support vector machine more accurate. That's an exercise I'm leaving for you. So do try to optimize it, and if you get better accuracy than this, the one stated here, do comment your accuracy and please share the code in the comment section. So let's move on to plotting the accuracies of different models. So let's move on to plotting the accuracies of different models. So first we will import matplotlib.pyplot as plt, then model, then we will declare a list which will be model name. For now it will be empty, and the model accuracy list, which is also an empty list. Then we will traverse our dictionary which we made, scores of different models dot items. We will append the model name with key and model accuracy with a value. Now we will define a variable which will be bar width and will be equal to 0.2, then a fig variable to adjust the subplot size, which will be fig size equal to 20,6. You can change it. Let do 20,5. So you can change it. I just like the 20,5 dimension because it was easy for me to visualize everything, but you can change it. So now we will use br1 dot, which will be equal to np.arange length of a model name list. You can also use model accuracy, we just need the length, both will be equal. So now we will plot the bar plot model name and model accuracy. Then we will set the title, which will be accuracy of different models. We will set the X label, which will be models. We will set the Y label, which will be accuracy. Then plt.show. Now let's run it. Here you can see we have wait a minute. We have printed all our accuracies of different models. So here you can see support vector machine, logistic regression, random forest, decision tree, k nearest neighbor, XGBoost and ADA boost, and all other models. So our project is complete now. You can optimize these models to get a better accuracy, but for now our project is complete. Thank you for watching the video. If you like it, do like, share and subscribe to my channel, and I will share this notebook and the dataset in the description, so you can check the links in the description for dataset as well as the code for this notebook. So thank you very much for watching the video. Thank you very much.